my goal for today is going to be Game Boy related. This little device right here, and two games with it. This is Tetris and Super Mario Land 2. And I have both of these games as a ROM file right here. And I basically want to learn how to A, write software for the Game Boy, and B, also learn how to write tooling to be able to write software for the Game Boy. So the idea is to eventually write an assembler in C, so I can then write ROMs or create ROMs, load them onto an SD card, and use something like EverDrive and just run it on the original Game Boy. Although I'm going to be starting with the emulator first, because it's much easier to just debug, and it's much quicker, right? If I can just create a ROM on the PC and then just put it into an emulator and see if it works or not, as opposed to putting it on an SD card and then on the actual hardware. And also, it's easier to stream. I don't even have any idea how to capture the display of this device, right? I know there is an interceptor card that someone in the ooh, this thing is dusty. Anyway, there's an interceptor card which allows you to capture the content of whichever cartridge you're playing and then kind of stream that on the PC. But yeah, I don't have that one, so obviously not going to be using it. So where was I? Yeah, so I wanna create an assembler to be able to write software for the Game Boy. At some point, I would like to create a disassembler, because if you already have an assembler, why not just create a disassembler as well, just for fun? It would be nice to be able to take any ROM files, right, and just convert it back into assembler code. I think that is a fun challenge to do. In some other future streams, I would also like to write an emulator, so that would be quite fun as well. Very simple emulator. I'm not going to be trying to be super, hardware correct, let's say. Although from what I know, the Game Boy is fairly simple, I think, relatively speaking. As a help, I have something special with me here. It's the Game Boy Programming Manual. Right? This is the official programming manual from Nintendo of America from 1999 to 2000s. As you can see here, it says, I'm not sure if you can read it, but it says confidential on it. So I'm not going to show too much of it, but this is basically my Bible that I'm going to use. It has all the instructions and how a cartridge, where the data in the cartridge lives and all this kind of stuff. It has it described in here. So yes, I'll be using that quite a lot. Unfortunately, since I can't really show anything that's in there, although I could tell you if you just Google the Game Boy Programming Manual, you might be able to find it on some, websites out there. Who knows? This is on gbdev.io, and this is community maintained documentation of, how the Game Boy works. It is mostly the same stuff that's in the manual as well, but also includes some additional things, right? So things that people have been figure out while hacking around with the Game Boy since. So, for example, what's a good thing to show? Well, since we're going to be dealing with the cartridge headers first, so for example here, cartridge header, all the information. So this is the page that we will be looking at a lot today, especially like this information, the license code that's in the cartridge header associated with actually trying to figure out which code belongs to which publisher. Since I don't own all the Game Boy games and cannot verify this myself, I'm just gonna be using this as the source of truth. You won't find this stuff in the official Game Boy programming manual at all, because why would they put it in there, right? This is like specifically only known to Nintendo, really. But I'm kind of jumping ahead a little bit here. So, let me explain. So the first thing I want to do, let's go to VS Projects and just put these two in here. So I have these two ROM files, Super Mario Land 2 and Tetris. And again, those are ROM files from my copies that I have right here. Every Game Boy cartridge has some information stored somewhere on here, which describes a few things. For example, there is, first of all, the entry point. I will explain all this in more detail, what that means. But basically, the entry point just means, okay, where in the sequence of bytes is the actual game starting, right? Then there's a Nintendo logo in there, which is for copyright reasons. So the Game Boy on boot up. Okay, I will explain that later. We find a title in there, we find a manufacturer code in there, some other information, like, for example, is this a Game Boy Color cartridge, or is this just a normal Game Boy cartridge? What else? Yeah, license codes, all this kind of stuff. So basically, there's a bunch of information stored in there, and I just want to be able to read it out. And what I would like to do is have a little command line program where I can just point to a folder and tell it, hey, go through all the files in here, assume they're Game Boy ROM files, extract all the header information, and put it into a nice Excel file. So I can then just, have everything in a nice table, look through it, whatever. Whether that's a useful program or not is another thing, but I thought it would be a nice thing to start with. So, new project, it's gonna be a console app. We are gonna name this GB Header Extractor. Why not? Fancy name. And the first thing we're going to do is delete all this nonsense because it's actually C++ and we don't do C++. Right, so properties, all configurations. So C language standard, we are going to take C17. We can have Unicode character set, that is fine. Linker, hang on, where is this? Like, I can never find the right page. You'd think after a while I just have this down, but wait, what? I feel like there's a page missing. Hang on. Why was this not there? Okay, whatever. Let's do enable all warnings. We set this to that. Yep. Output files, assembler output. Sure, would be interesting to look at sometimes at least. There we go. Compile as C code, please. Okay. And now somewhere here, I can specify the runtime to use. Where is it? Oh man, it would be nice if they just had a search field in here, you know, just like, I guess that would be too much to ask. Runtime library, there it is. So we need to go into the specific configuration here. I don't want the debug DLL, I want the statically linked one. And for release, it's gonna be this one. Okay, cool. Let's get some basic copyright shit going. Okay, this is gonna be GB Header Extractor. Version 0.1. And it's being created in November. What do we have? 16th. Okay. So CRT disable perf create logs. This basically means that the C runtime functions are no longer multi-threaded, so they no longer take locks. Because I know this program will just be a single thread. I'm not planning on adding any multi-threading whatsoever, right? So we can just disable these ones, and it will then start using certain functions that no longer acquire a lock. So it should be a little bit faster, basically. Let's just put it that way. On the Game Boy cartridge, what you can imagine is there's some sort of chip in there that stores your whole game, right? So on every cartridge you have like a single chip on there with a specific size. Let's say in terms of Tetris, it's actually 32 kilobytes, sorry. So there's a chip on here that consists of 32 kilobytes of data. So it's just a sequence of bytes, which can either be instructions for the CPU, right, to tell the Game Boy CPU what to do next, or it can be, I don't know, game graphics, or music, sound files, anything really, right? What I want to do today is, in this block of bytes, that is the cartridge, there's a specific section in here that is reserved for very special data, and that is called the header. The header information is on address 0100 and goes to 014F. And all these bytes have a very specific format that is specified by Nintendo, and describe all these different things that I mentioned before. So who's the publisher, what's the game title, and it also contains like the Nintendo logo for copyright reasons, because the Game Boy and boot up will actually check that the cartridge is a real cartridge by going through all those bytes and making sure it's the Nintendo logo. Otherwise, it won't boot, so the cartridge would work. So what is a ROM file? A ROM file is essentially all the memory contents of the chip here being extracted via a device and just put into a file, that you can then copy around or use on Windows. Nothing more. It literally is just, you plug into the device, you run a little program, it takes all those bytes from this memory chip, writes them into a file on your system, and then you can use it. In an emulator, you can open it as any file whatsoever. This is all the bytes of the Tetris ROM, shown as hexadecimal. So this is 1 byte, this is 1 byte, right? And this is exactly all the contents of the chip, just copied into a file on your system. That's it. And as you can already see, some of these hexadecimals can be interpreted as ASCII, and we can already recognize here Tetris. Right? So this sequence of bytes spells out Tetris. And it is on address 134, right? Hex, that is. And as I mentioned before, the header starts on address 100 and goes to 140F. So this is part of the header. In fact, all these bytes that I just have highlighted here are the header bytes. So what I want to do is then read out those headers and put them in an XML file. So how do we start? Let's start by just opening the file and read out basically this part of the header and see what we're getting. Just in raw bytes for now. We're not trying to interpret them just yet. Okay. So let's do that. Start with int main. We have the argument count, and we have the actual arguments. Okay, return exit success. Okay. And because I do not want to have code in there that I do not want to bother with selecting the folder and all this kind of stuff just yet. All I want to get done now is trying to extract this header information out of this file, right? So I'm just going to plop the file here, and we're just going to hard code the path into that file for now. Actually, I do not need to copy this in here, right? Let's just leave it down here. Copy as path. Okay. Let's call it file name. Okay. I can make this const, whatever. Doesn't matter. So this is our Tetris ROM. We call fopen to open the file. So let's call this ROM file. Take pointer of ROM file, I suppose. What did I just pass in this? This. Okay, then we have the file name, and then the mode is RB for read binary. If fopen didn't work, returns an error code. Actually, let's check. I'm using the save mode, which is Windows only. So this code will not be portable at the moment, but I'm not going to worry about this at all because I don't care whether I'm portable or not for the time being. It would be nice to get this onto the Mac as well at some point, but for now, I don't care. So let's see. We have yeah, R is for read. Yup. B, open in binary mode. Yes, that is exactly what we want. Okay. Otherwise, we print an error. Fail to open Tetris GB ROM and return exit failure. So if we cannot find the ROM, we will fail. Actually, we can just check the. Yeah, there we go. Cool. So, and if we now say GB F close. Although strictly speaking, not necessary that we close the file. Yeah, cool. So we now have open and closed the file. Oh, and as you can see, disable perfcrit locks. If I go to fclose, we will notice that fclose is just a macro, and it tells us what it actually expands to. And if we click on it, we can see it expands to fclose no lock, right? So this means it's using the non-thread safe version where it has no locks. There we go. As opposed to if I would comment this out, fclose would just be a direct call to fclose, which is the one that is taking locks. So it is no longer macro. So just thought it might be interesting to mention. Anyway, so what we then can do is, let's say, well, I mean, okay. So the most efficient thing to do is to read a large chunk of a file at once, usually, right? So a file read buffer is usually like what, well, it depends on the hard drive that you have installed and what the sector size is, but usually you want to read the exact amount of bytes that is exactly as large as the sector of your hard drive, which I know on my system is around 4 kilobytes, right? So what I would usually do is just read 4 kib at a time. In fact, you know what? It doesn't matter. We can just do that. So let's just do that. Let's have a. Okay, I have a little typedef file here, which I'm just gonna copy into this project. All it's doing is like it's giving them signed char and unsigned char my own names because I kind of like using those instead of the officially defined ones. So include typedef h. So we have an array of U8s. This is gonna be our buffer, and it's gonna be 4 kib. Okay, and then we just gonna do one call to fread, actually fread s, I suppose. The destination buffer is gonna be our buffer. The destination size is, actually, let's make this a define buffer size. Right. So we can just reuse that. The element size is gonna be size of U8. U8 is just an unsigned char, which is 8 bits, right? So 1 byte. And the amount of data we're going to read is also buffer size, and we're going to read it from this file, which we called ROM. Oh my god, I can't type. Which we call a ROM file. If so, we're getting the thing back that we just read. Since ROM files always have a fixed size, and the smallest size of a Game Boy ROM is 32 kib, right? So 4 kilobytes, we will never be able to read less than 4 kilobytes, or at least shouldn't be able to read less than 4 kilobytes out of this ROM, because there's 32 kilobytes available, right? So fread returns the amount that has been read by this call. So we're just going to make sure it is the same amount as buffer size. And if it is not, we're just going to print an error, I suppose. What are we putting? Is this really a Game Boy ROM? I'm gonna put it to std. And why is this complaining? Okay, whatever. Gonna return exit failure. Now, suppose it's nice to actually close the file, but we don't really need to do this since the operating system will close everything for us once we go out of main. It will close all the open file handles. The only time when it doesn't close all the file handles that are still open is if your program crashes via segfault or anything like that. Then it's just all hands off. Okay. Okay, I really don't know why it's... Type name is not allowed. Oh, size off, not just size. Jesus. Okay. Weird that it then marked this one and not this. Wait, is size actually a thing? No. So why did you... What? I don't know, man. Okay, whatever. So let's make a breakpoint here, and if we actually reach that breakpoint, we can see if we type in buffer that we now read 4 kilobytes of data from that file. All right. So in this case, let's say define header start will be on 0x100. 0x is just a way of defining hexadecimal in C, so this means 256, right? And define header end. So this is do we want to be inclusive or exclusive? I would just take the exclusive amount, I think, because that is kind of easier to deal with. So it would be to hex 150, right? What's 150? Well, let's figure this out. Plus 50 is position 336. Now, on position 336, that byte is the next byte after the header, so it does not belong to the header anymore. On position 335 is the last byte we care about. That is the header data, right? So, and what we now can do is You know what? Let's print it out byte by byte, I suppose. Just for now, for fun, right? So for let's say size t pi equals buffer, no, not buffer, we called it header start, and if I is smaller than header end, increment, there we go. And what we then can do is say printf, so percentage 0 to x. So this means hexadecimal, this means 2 spaces, and fill the other one up with 0, I suppose. I might be telling bullshit here, so please take it with a grain of salt. And we have buffer and just get the byte position I, right? So let's just put a new line. Why not? That will put new line, but whatever. So if we run this, okay, interesting. What did I fuck up? I am a bit rusty, it seems. So we have header start, header end, increment, we do a printf, what? Access violation. Oh, what's this the problem? Oh, can't it be a single character? Oh, because of the missing slash null. Never mind. That was me being dumb. There we go. And these are our bytes. And now if we look in the hex editor that I had before, let's just go here. And we can confirm that they're the same. 00, C3, 50, yep, all the way to 0A16BF. There we go. We successfully read out the header. Now we can start interpreting that information. The first 4 bytes, right, from 00 to 03 here, or rather 100 to 103, describes the entry point of the ROM. Let's actually make a comment on this. So 0x100 to 0x103 is the entry point. This essentially, after the Game Boy has read the header information and made sure that the cartridge is actually a properly licensed cartridge and not some fake thing, right? It will jump into this area and will read out those 4 bytes. And those 4 bytes will tell the Game Boy of where in our huge chunk of memory the game actually starts, right? So how this is exactly done, I will explain once we write an emulator. But just imagine right now, those 4 bytes describe the start of the game, right? So where does Tetris begin? Going from 0x104 to 0x133. That is the Nintendo logo. So 133. So right up to before we see Tetris starting. This sequence of bytes is the Nintendo logo. Now, what does that mean? So this is a very actually. Maybe I can show this. I don't have any batteries in the Game Boy. Shoot. But essentially, when you start the Game Boy, you see the Nintendo logo coming down first. I'm not sure if you guys ever seen that. Do I have any batteries in here? Hang on, I might have some batteries. Jackpot. Okay. Takes 4 of these suckers. Now I hope they're charged. Whoa! Okay, so I'm putting Tetris in, right? And I'm gonna boot it up. Do I have the contrast set right? Hang on, otherwise you won't be able to see anything. Okay, so I'm booting it up. Nothing happens. Well, that's a good start. Oh no. Oh dear, oh dear, oh dear. Nope. No! Don't tell me nothing is charged. Oh man, I'm so unprepared for this. Let's see. Ah! Okay. There we go. We're starting. You saw that? That Nintendo. Oh. Wow, okay. That is a bit. I think my contacts are dirty. There we go. Yeah. So this Nintendo logo right here. This is exactly encoded as this chunk of bytes that you see here, right? And what the Game Boy is doing on boot up is it is reading that Nintendo logo. It is comparing the bytes with its own Nintendo logo that is somewhere stored on the system and makes sure that those bytes are exactly the same. If they are not, the cartridge would just not start. You would see some gobbledygook scroll down and nothing else would happen. In fact, you can do that by removing the cartridge and just turning the Game Boy on. Right? You hear the chime, but you don't see the logo. Now, why don't you see the logo? Because there's no cartridge in there, and the logo is not in the header. So, the Game Boy says like, hang on a minute. I don't know what the fuck this is. So I'm just doing nothing. Okay, turns out I need to charge all these other batteries here. So that's good to know. Just gonna leave them out here. So yeah, this is the Nintendo logo. Now, why would you ask? So, if you were someone to write a bootleg Nintendo game without Nintendo's approval, why not just put the sequence of bytes in there and pretend like you're a licensed Nintendo game? which is like, hey, that is a very good idea, except the Nintendo logo is copyright protected, which means once you put that into the header, you're breaking copyright law, which means Nintendo can come after you, right? So that was one clever way of copy protection. Like, nothing stops you from just taking the sequence of bytes and, shoving them into your bootleg ROM, and it all would just work. I think a lot of games actually did that, probably. But yeah, Nintendo could come after you for that, because you're technically violating copyright law. Okay. Now, what comes after the Nintendo logo? Because we're just on position 133 hex, which, we know we need to go up to position 149 hex. So the next thing, starting from 134 to, let's see, 13E, right? This 11-byte sequence is the game title. How is the game title encoded? So the game title is encoded with an ASCII table, and I think I can show you this at least, as you can see right here. I'll have to wait and see until the camera catches up. So yeah, this is the ASCII table, which describes which byte belongs to which character, and any of the other ones is an illegal character, right? Title, these bytes contain title of the game in uppercase ASCII. If the title is less than 16 characters long, the remaining bytes should be padded with 00. Cool. Right. Okay, and this is where the first discrepancy comes in. So this is from 134 to 13E, which is 11 bytes, right? But this document claims it goes to 143, being 16 bytes. Or just to 142, being 15 bytes. And I think this is dependent on which kind of cartridge you're actually using. So the very first cartridges started out with 16 characters as the title, and then later on moved to 15 because some other information was encoded in there, to now in the Game Boy Color era, I think, where it's just 11 bytes. Interesting. Well, we're just gonna follow the specs from this manual for now, from the official Game Boy programming manual, and pretend it's 11 bytes for now. But let's make a to-do. 16 or 15 bytes, depending on cartridge type, right? Okay, actually, let's try to read out. I'm not quite interested in the entry point now or the Nintendo logo. I'm not going to touch that, but I am interested in the Game Boy title, right? In the game title. So let's see if we can read that one out. So since this is uppercase ASCII, what we can do is have another buffer here, which is call it title. It's 11 bytes long, right? Destination title. Size in bytes would be... Actually, we do not even need to copy this, right? All we can do is just print it out, to be honest. Can I? I mean, I could, but let's copy it. Size in bytes would be 11. Source would be buffer from 0x134, and the max count is 11. Actually, let's make it 12 bytes. Yes. So, because this cartridge game title obviously doesn't care about null termination of strings in C, so you could fill up all 11 bytes with actual valid data, right? And but we just want to copy 11 bytes and make the last one 0, I suppose. I mean, it's probably better if we initialize it then to 0. Does that make sense? Maybe. Whatever, let's just copy. And then what we can do is let's remove this. And then printf actually puts title. There we go. There we go. The title is Tetris. Sweet. Let's inspect the title bytes. All right. Tetris /0 and the rest is uninitialized. Okay. Cool. Now let's try the same thing with the other cartridge that I have. Right. Choop. Okay, Super Mario Land 2, 6 golden coins. Mario Land 2. Nice. Yep, there we go. As you can see, Mario Land 2. Sweet. Now, the ASCII codes are fairly consistent with the C ASCII codes, with one exception, and that is this thing right here, which is the, I'm not sure if you can see it, it is the yen symbol. So we can go to the immediate window and actually do that. So if I say char, and what is it? It is 0xc5. No, it's 5c. Right. As you can see in the normal ASCII table, it is a backslash, right? But actually, in terms of a Game Boy cartridge, it is supposed to be the yen symbol. So that is one thing to consider once I put game titles out into the Excel file. One thing to watch out for. Okay. Now we have this is 213E, right? So 13F 20X 142. That is the game code. Yeah, manufacturer code. In older cartridges, these bytes were part of the title. In newer cartridges, they contain a 4-character manufacturer code in uppercase ASCII. The purpose of the manufacturer code is unknown. Alright then. But basically we can do the same thing here. Let's see, because it is ASCII characters again. Let's say code. There's 4 bytes, hence we want 5. To initialize this really. String copy yes, we want the code, which is 5 long. We want to go from buffer, and we start at position 13F, and we just want to copy 4 characters. Alright, that we will our game code, and then we can print out the game code and see what it is. So for Mario Land 2, the game code would be nothing. Right? Because Mario Land 2 is probably one of the older cartridges. Let's do Tetris. Also nothing. Because again, Tetris is one of the older cartridges. In fact, it was bundled with a Game Boy on release. So I do not have cartridges that have a game code attached to them. But we'll figure something out for that, I suppose. Now, the next byte after the game code indicates whether this cartridge has Game Boy Color support or not. Right? And how this works is, let's check in the manual. There are 3 possible support codes. So there is, for one we have 00, which means Game Boy only, right? So if we have a hex 00 in there, that just means this is a Game Boy only game, which Tetris probably will be, so I expect to see a 00 on there. However, Game Boy only does not mean it will not run on the Game Boy Color, right? It will still run on the Game Boy Color. It just means it does not have any Game Boy Color features, right? It doesn't utilize any new features. It's purely meant to be written for the Game Boy. But because the Game Boy Color was sort of backwards compatible, it can just run the cartridge anyways. The other possible option would be 0x80, which means it is Game Boy Color compatible, right? What does that mean? It means this game will run on the original Game Boy, And if you put it in the Game Boy Color, it will utilize some specific new Game Boy Color only features, right? So it's a game that's exclusively written for both. And then something that we won't counter just yet is C0, which basically means Game Boy Color only. This game will not run on the Game Boy or Game Boy Pocket. It will only run on the Game Boy Color. Now, unfortunately, I do not have a Game Boy Color cartridge here, but there is actually a hardware sort of safety net there. You see this little nook right here, this little missing piece on the cartridge. You'll notice if you put it in the Game Boy and actually turn it on, it hooks in, so you can't take the cartridge out anymore, right? And Game Boy Color games do not have that. So if you put a Game Boy Color game in here, you won't be able to turn it on because you just physically can't, right? If I remember correctly, they also have like a little bulge, which should prevent for going like. No, I think the bulge actually would still fit. I'm not sure. It's been a while. But yeah. However, I think the Game Boy Pocket, although I never had one, doesn't have this little mechanism. So I think technically you could put in a Game Boy Color game into the Game Boy Pocket, and I think what you would see is just a little notification that says that this title is not compatible with this system. I think they accounted for that, and this is why the little why the hex code is there, because I think the Game Boy Pocket reads it out. Let's see what the Pandocs have to say to that. Color Game Boy flag. In older cartridges, this byte was part of the title. Okay. The Color Game Boy in later models interpret this byte to decide whether to enable color mode or to fall back to monochrome, right? Okay. Yep. So, now the interesting part is, how did that work when this byte was still part of the title? Because as you can see, 0143 is part of the title for older cartridges, right? What if there was an old game with an overly large title? Well, that's easy to answer actually, and it's quite nifty. Because if you look at the uppercase ASCII range, whatever we set can only be in this range here, right? And 80, so 80, is an illegal character anyways, so a title would never use that. And then for Game Boy Color we have C0, which again, C0 is an illegal character, which a title would never use. So it was quite safe to do that, which is quite nifty, I think. And the same applies for the game code, right? Sorry, the manufacturer code. Because all of these could just be any character in the invalid ASCII range, so they can just be ignored. That is good to know. I'm not quite sure how to figure out whether a cartridge is an old cartridge or a new cartridge. So let's see. So if actually let's make this a switch, right? This is buffer on position 0x143. So we can either have a 0x80, which we can then say GameBoy Color compatible, or we can C0, which is GameBoy Color only, or we can have a default case, which is basically everything. I should have breaks at the end. Must not forget the breaks. So in which case we can just say printf old title byte equals what was the hex thing, 02x. We can just print out the bytes. And of course we put the new line. There we go. So now if we run this, we see Tetris as an old title and the byte is set to 00. Right. Let's say color mode. Actually, kind of want some extra information here as well. This is the game code, right? And then we have printf with the title. Cool. Title Tetris, game code non-existent. Yeah, whatever. And then color mode. Yep, cool. We can test the same thing with my other cartridge. Sweet. Cool. Okay, still a few bytes left. The next 2 bytes after the Game Boy Color support, so from 0x144 to 0x145, this is the maker code, a 2-digit ASCII code assigned by Nintendo. Contact product testing if in doubt. I don't think I can reach them anymore. Or they would have some serious questions if I tried to contact them. Okay, it's all ASCII code letters. Let's see what the Pandocs say. New license code. This area contains 2 characters. ASCII license code indicated the game publisher. It's only meaningful. Wait. It's only meaningful if the old licensee is exactly 33. Right, that is a very specific byte that is set. Ah! So, okay, there's two different license codes, right? There is one before the Super Game Boy came out, which was just a simple byte that would indicate one of these publishers, right? So let's say byte CA will be Ultra, whoever Ultra is, right? Konami would be A4. Okay. However, if this byte is set to 33, it indicates that you need to use the new license code, which is these 2 bytes. And these 2 bytes are encoded in ASCII characters. And if you take both of these ASCII characters together and interpret them as a code number, you get the new publisher. For example, ASCII 1 and ASCII 3 would mean this is Electronic Arts. Okay, interesting. Right. Okay, so 14B is old license code. Okay, so we just take this whole table. There's a lot of publishers, Jesus. Okay, so case 00, that means none. Okay, let's do it this way. We have maker, right? Old maker equals none. Okay. Then we have case 001, and this is old maker. Oh my god, just copy paste. Equals Nintendo. Break. It is a lot of publishers. Oh dear, oh dear, oh dear. Okay, this indicates that the new licensee should be used instead. So we're making something special here, right? I'm just gonna make sure everything kind of looks alright. So, and actually let's rename this just to maker. Okay. And then what we can do is print out printf make code. Right, the other one was the game code. Right. Sorry, got confused there for a second. Make a code. No, let's just call it maker. And the maker will be whatever is in maker. Right. Meet thy maker. Meet thy maker, Tetris. Okay. What? What did I do wrong? Where did I fail? Right, okay, because we want the default case in there that actually sets maker to null, right? And if maker is null, we do something else. Printf unknown maker. don't need to. I can just say puts. Cool. Actually, even better. If maker is not, let's not set it to null at all. Let's just set it to unknown. Right. Let's print it out like this. Much better. Cool. So Tetris and the maker is Nintendo. Sweet. Who would have thought? Nintendo made Tetris. Well, they published it at least. And there you go, Mario Land 2, and the maker is also Nintendo. Sweet. What about the new maker code? So if we have this old thing here, we want to do something special, right? New maker code should be used. What we can do is we can say we are a U16, right? That is the code. And what we can do is, so this is little endian, so the least significant byte is first, right? So if we have buffer in this position, and we make this U16, and we shift this over by 8 bits, and then we can say code and say buffer right. So this should be our code. Actually, it's a shame that I put all this work into this massive switch statement and now I'm changing it, but whatever. Okay. Shift this right, or it with this. So what we now should end up with is just a short number, which we can switch over, right? Okay. Now this. Right. It's okay. So this would be except the A down here, which would be, what did I say? 40, 41. Okay. Oh, man. Okay, and that would be this, right? Except there might be some things lurking here, like the H right here. Okay, ASCII H is 48. So 30, 30. Okay, and now we can, oh my lord. There we go. This is our new list. Cool. So we took two different ASCII values and basically made a different number out of them. So we can just compare it over one shot. So I don't have to go there byte by byte. I think it's just a little bit neater. All things considered, from the Game Boy lifetime, there's not that many publishers, is there? Okay, if you compare it with the old ones. I mean, some of them might have an overlap. Sure, Interplay is probably down here as well somewhere. Maybe not. LJN sure is. For those who don't know, LJN released some shitty games. Some really shitty games. Okay, so the next byte after the maker code, that is the new maker code. So 0x146 will be the Super Game Boy support code. Now, what does that mean? Super Game Boy support code. Let's check. Okay, so there is only one special value, really. So it's either 0 and probably anything else, really. Means this Game Boy game can be run on the Super Game Boy. For those who don't know, the Super Game Boy is a special cartridge for the Super Nintendo. So you could play Game Boy games on your TV via the Super Nintendo. In fact, it's this little thing, right? So this would go into the Super Nintendo, and you plug in your Game Boy game in here. Done. So, and you can basically play any Game Boy game on the Super Game Boy. There's also special Super Game Boy features, which I do know nothing about. So if there's a value that is 03 in hex, then this game uses Super Game Boy features. If it is 0 or possibly anything else, Okay, so since these are not special cartridges, in fact, I think both of these came out before the Super Game Boy. Not quite sure, to be honest. There probably will just be 0 on these cartridges here. So let's say switch buffer 0x146 case 0x00. Okay, Super Game Boy mode. In this manual, there's a whole section on the Super Game Boy of some things that you can do. So I think it's a bit more than just wallpapers and stuff. But I never really had a Super Game Boy as a kid, so I don't know what features exactly there are. And even though I have this now, I have not tested it yet. So I don't know if this unit even works. And in any ways, I only have these 2 games, so I don't think they have any special Super Game Boy features anyways. I might have to like figure out which games utilize the Super Game Boy and then just see if I can find them somewhere and try it out. Okay, this is a normal Game Boy game. Whoops. But if we encounter code 0x03, it is a game that has Super Game Boy features. If it is anything else for now, we just print unknown. Just for the sake of it. Print F. Super Game Boy mode. Super Game Boy mode. Okay. Don't forget your new lines. Whoops, still at a breakpoint. Excuse-moi. Okay, so this is just a normal Game Boy game. Fantastic. Actually, let's try this with... Oh, I tried this with Super Mario Land. Right, then Tetris won't be any different. I'm very sure of it. So if we try this with the Tetris ROM, yeah, just normal Game Boy game. Cool. Actually, it's Tetris. So we're almost done with the header. Almost. Okay, it can be any other value, so there is no unknown. So if it is anything but this, it's a normal Game Boy game. Right. So the next thing is the game pack type or cartridge type. So this basically is where it gets into the technical stuff, right? So actually Super Mario Land, for example, is a bit larger, as you can see. So it's 512 kilobytes, while Tetris is only 32 kilobytes. What that means is that this one has obviously a bigger chip in there because it has a lot more data to store than Tetris. So it is a much larger game overall. And I mean, yeah, lots more sprites, worlds, graphics, right? And so there were different cartridge types that were able to address specific amounts of memories. So as you can see here, for example, on the code, it says ROM only. So what does that mean? One ROM is just 32 kilobytes. It's just a simple chip, no controller, nothing else, very simple logic. It's just one chip, and that's all the data the Game Boy can address, like 32 kilobytes. Some games, however, were a little bit larger, so how do you fit them in there, right? If the Game Boy only recognizes 32 kilobytes, um, games like these that use more memory usually come with a memory bank controller, which is a separate chip, which you can talk to, which would then basically flip. Hang on, I can draw it out. It would determine which chip is the active one for the Game Boy to use, right? So let me fire up my tablet real quick. Hang on. Oh, hello. My dog just jumped off the bed. Hi. Let's say hello. Say hello. There we go. Little one. There we go, my little one. Oh, the camera is not focusing. I'm too far away from the cam, it seems. Do you have a good sleep? Yeah? Alright. You can stay here if you want to. Okay. Yep, there we are. Let me switch over to the tablet. So, basically, as I said, the Game Boy can only recognize 32 gig. That's the maximum amount of memory a game can have without some special controllers, right? So this is one RAM chip. Now, games that would have needed more data would usually pack additional 32 kib chips in here, right? Something like this. Let's say we have 4 different ones of these, right? Sorry for the writing, my dog is laying on my hand, so I have difficulty moving it. Let's say, for example, we have a cartridge with 4 of these, and then we have a specific memory controller, right? Controller that would indicate which one of them is the active chips. So those can be numbered from 0, 1, 2, 3, right? So the game would start here with the header data and everything, right? And it would run its course, and at some point, let's say you want to switch to the next level, it no longer fits into this memory, right? Because it has some special sprites or whatever, so it is on the next chip. So what you then would do is talk to the memory controller in the cartridge and say, hey, switch your memory to page number 1. And then it would no longer reference to this one, but it would switch to this. Now, in the view of the Game Boy, nothing really changed. It still thinks it's pointing to the same old 32 kib it has been pointing to before. But we effectively just switched it out underneath it, stealthily, and just pretended like, hey, you know, just pretended it's the same one, even though it's a completely new set of memory. Basically, there were fixed sizes for these memory chips because Nintendo was manufacturing all the cartridges, right? At least I think they were manufacturing all of them. But yeah, not only could the size of the memory vary within these cartridges, but also they could have extra RAM that the Game Boy could address. And they also could have batteries, right? So some games would allow you to like store save games on the cartridge, and that was done by having like a little battery there for like some low voltage saving to constantly power the chip where your data is being stored. You might have heard for some of the problems that some of the batteries, have been dying recently over the years, so you would have to unscrew the cartridge and put in a new battery. Obviously, if you take the battery out, your save games are lost, so tough luck. This is where emulation is really useful, but I'm getting ahead of myself there. So yeah, they could have different RAM sizes, different ROM sizes. To explain, ROM is read-only memory, so this is where usually the game data would be stored and the game code, and RAM is actually random access memory, but basically it's memory that you can override during the runtime, so you could actually change things. So yeah, battery, some of the things, I mean, it's easier to just look at the list if you look at this. So MBC1, for example, was a specific memory controller that had a certain size, right? Memory bank controller 2, I think, was also specific size, not quite sure. Well, we'll get to this. We learn all about this. But essentially, as you can see, some of the cartridges had batteries attached to them, then a timer, which is a real-time timer that constantly ticks at the fixed rate. This is especially important for games that, need to deal with real-time stuff. So, for example, Pokemon, I think. I don't quite know. We'll have to figure it out. There's also cartridges that had rumble packs attached to them, right? There is one with a sensor and a rumble pack. Then we have a very special one, which is the pocket camera, and some Bandai ones, and I don't know what these two are down here. HUC. No clue. So yeah, and all these different cartridge types are specified based on this byte value right here, right? So let's copy that table and just do this, and this is 0x. We can transform this into a case. Let's call this cartridge type. Multi-line editing is so much fun, honestly. I love it. Okay. So what we have is unsigned 8. What did I call this? Cartridge type. Right. And no, what am I doing? This is a string that we want to set. So, and we have a switch in buffer position 0x147. And this is our case, right? And we have faults, which is cartridge type unknown. Break. Cool. And then we can say printf cartridge type %s and a new line, of course, cartridge type. Cool. Which game do we have set? Tetris. So Tetris will just be ROM only because it was the first game ever released. It fits into 32K just fine. So let's see if that's the case. And indeed, cartridge type ROM only. Now, However, Super Mario is quite bigger, right? It's 512 kilobytes. So we should see something else pop up, one of these. And indeed, what does Super Mario Land 2 have? It has a memory bank controller 1, it has extra RAM, and it has a battery. There you go, ladies and gentlemen. I mean, we could probably verify this if I unscrew the cartridge. But I have the wrong screwdriver head in here. Hang on. Let's do this real quick. Why not? I hope I have the right bits. I mean, so far my iFixit kit has not disappointed me, but indeed. Sweet. Let's do this. Haha! There we go. Yep. Okay. So. Sorry, I'm just reading the chip descriptions here to maybe try and figure out which is which. But I cannot distinguish the bottom chips. Okay, but as you can see, we indeed have a where we are. We indeed have a battery, and this chip here actually says on it MBC1 B1. What do we see in our console application? Cartridge type MBC1. So this is the memory bank controller that is responsible for switching out the different pages of memory, right? And then we have two extra chips down here. I don't know which one is which, but one of them is the ROM, where the game is living, and the other one is the RAM, which the Game Boy can use. I think the bigger one is probably the ROM, because I think the RAM is smaller than the ROM. Don't quote me on that, I'm not sure. But in any way, there we go. Let's close this back up. There we go. Like nothing ever happened. Actually, I'm not sure if the battery is still working that's in here. So I should probably switch it out, but I don't think I have a battery quite small enough. I have like these big boys here, but yeah, I think I need smaller ones. I'll figure it out eventually. I haven't been playing these games in quite a lot. To be honest, I have not been playing cartridges directly. I have downloaded the ROMs of these, and I have an analog pocket where I'm playing stuff on. The analog pocket allows me to have save states in there without using the cartridge battery, so that has been quite useful. Okay. Right, on to the next byte. We have still a few bytes left. Actually, the next two we can do like in the same go. So this was the game cartridge or game pack type. The next byte after it is the ROM size, and the other one after it, the RAM size. And that means the extra ROM and RAM chip that you just saw in the cartridge. So what size do they actually have? And then we can see here, ROM sizes. Right, so these three down here are only listed in unofficial docs, but no ROM have ever been using this. So we just completely disregard these values because no one apparently knows where they're coming from. But these are the official ones. So we have 0 for just 32 kib, which means there's no banking involved, right? Then we have a value of 1, which is 64 kib. We have a value of 2, 128 kib. Number 3, 256 kib. And then we have 04, which is 512 kib. And I expect to see this value for Super Mario Land 2, right? Because it is 512 kib. Now, there's also different ones which go into the megabyte range, but as far as I know, these megabyte large games are only Game Boy Color games, because they obviously need to store a lot more information because of all the color information in there and things like that. Right. And then we have down here the ROM size as well. So 0 means there is no extra RAM, which is what I expected to see for Tetris. Okay. Yeah, let's do it this way. Okay. ROM size, switch, buffer, and this is on position 148. I should probably update the stuff up here. 0x147. This was cartridge type. Why do I find typing cartridge so incredibly difficult? That's weird, man. Okay, and this is the ROM size. And 149 is RAM size. Now, I am not sure whether the Game Boy actually used these values in any way, or if it was just internally for Nintendo to figure stuff out. Because as far as I know, the booting just tries to compare the logo bytes and the header checksum, and that's about it. So, who knows? I'm sure it was useful information to someone at some point. ROM size. Okay, this is 32 kib, right? And then we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. And then we have 64 kibs. We have 128. 256. Always a power of 2, I suppose. 512. Then we go into megabytes. 1 MB, 2 MBs, 4 MBs, and 8 MBs. Cool. Default. Fuck knows. We write it a bit nicer. Just unknown. Okay. And then we print that out. That is the ROM size. ROM size. And now we do the same with the RAM size. Switch on buffer 0x149, right? We have 0, we have 2, 3, 4, right? And then we have default, which is RAM size unknown. Okay, 2, 3, 4. So no RAM. Then we have 8 kilobytes of RAM. Then we have 32 kilobytes of RAM, and then 128 kilobytes of RAM. Yep. Cool. Print this out as RAM size. Okay, Mario Land 2, and there we go. A ROM size of 512 kib, and the extra RAM size is 8 kilobytes. So Super Mario Land 2 has 8 kilobytes of extra RAM. Neat. Okay. And if we now do this with Tetris, it should indicate what are we expecting to see. We expect to see 32 kibs of ROM and no RAM. And indeed, ROM size 32 kib and RAM size no RAM. Cool. The next one is the destination code. 14A, right? And then we already have the old license code. Okay. Destination code. Now, what is the destination code? Basically, it's just an indication of where this cartridge is supposed to be released. And I find this incredibly nice because there's only 2 codes. There's 00, which is for the Japanese market, and then there's 01, which is for everywhere else, and sometimes Japan as well. So basically, the only distinction we have here is this cartridge for Japan only, or is it for everywhere? This is what you get when you have a Japanese-focused company like Nintendo. Okay, destination, right? We have a switch, buffer 0x14A, and we have case 00, which means the destination is Japan, right? And then we have case 01. Check here, destination code, Japan and possibly overseas. Oh, okay, interesting. Or overseas only. I thought it was the other way around, that overseas only also included Japan, but apparently Japan can also include overseas. Try and make sense of it. I don't know. So default. We just say destination unknown. And then we do printf and destination %s and destination. There we go. So now we're still on Tetris, I believe. Yep. Destination Japan. Interesting. Because this is... Huh. Wasn't Tetris only bundled in Europe and America, though? Somehow these codes don't make sense, do they? Let's see, Mario Land 2. Oh, this one is marked as worldwide. I don't get it. I honestly do not get it. Right? Oh well, let's just move on. So we have one more thing. I kind of want to take a break because my food just arrived downstairs, so I'm gonna have to say goodbye soon. But I want to get these two things done. So we got the destination code. The next is the 33-bit. Yeah, we got that. That is the old destination code. And then we have the ROM version. Right? And the only thing this indicates is the version of the game. Hang on, where do we have this? Yes, so the ROM version would start with code 00. Every single time you have put forward a new version for Nintendo to verify, the version would increase by 1, right? So let's say you have version 00 and then you go through the process again because let's say you re-release the game with a different packaging and maybe fix the bug that was accidentally shipped in the first version, then it will be version 01. And then so on until, like, I suspect most games have probably just 00 there, but I'm just making that up. I don't know for sure. So let's check with the two ROMs that I have right there. I think we can just print out the version bit as is. So we can just say printf version. It's a decimal. And then this is just buffer location for C, right? I think. Yeah. Cool. So let's start with Super Mario Land 2. Version 2. Interesting. So the version that actually shipped to customers is version number 2. Well, sorry, no. Because it starts with 00, right? And every time you increase by 1. So this is version 3. Okay. Now, what is the version of Tetris? 1. Nice. Cool. And that is about it for the header. I mean, it goes on a little bit more. But I don't think I need to talk about these values now because they're not really relevant. Like, they don't give us any information similar to, like, you know, the entry point or the Nintendo logo. It's just some checksum version. So this is 14B20X14F. What this is a complement check number. And then here, change the formatting at some point. And this is the checksum of the entire ROM. ROM. Okay. So basically we have 1 byte, which is a complements check. And all that is doing is, hang on, let me find the section. Yeah, so basically this is sort of a checksum for all the header data. So you would just add all the bytes of the header data together, and whatever you added together is a specific number, an 8-bit number, which is stored in this field right here. And the reason for having that is if someone tampered with the header data. So let's say the Nintendo logo is valid, but they changed the title or whatever to say something funky, or they changed the version number, but have not updated the complements check, then it's an invalid header, basically. Now, whether the Game Boy checks for this or not, I don't think it does. It probably was just from internal development tool or something. I'm not entirely sure on that, but we'll find out in the course of these streams, because I will definitely do a lot more Game Boy streams. And the last 2 bytes in the header are the checksum of the entire ROM. So you would take, for let's say Super Mario Land 2, you would add all the bytes together, and at the end you have a 16-bit number, which is the checksum of this ROM. So if someone somewhere would hack the game, for example, and change some of the bytes in there, the checksum number would not be updated, and you would recognize that this cartridge has been tampered with. Now, it's not foolproof. You can still change some of the bytes and still come out with the same checksum, but that's besides the point. I don't think it has been used in the Game Boy anyways. I mean, the Game Boy certainly doesn't check that checksum. That I know, because that would be quite computationally expensive for the Game Boy. Yes. And that's it. I'm gonna stop here. So at least we are now able to read all the header data, at least all the interesting bits out of the ROM files. Now, next time what I would like to do is be able to put this into an Excel file, so to have a nice table, and then just specify the program, hey, go through all these ROM files in this folder and put them in the Excel table and spit me out all the information there. Why you would need this, I don't know. I kind of find it interesting. If you have all different ROM files and just want to check out all the header information and stuff like that, who the publisher is and things like that, I find this stuff interesting, so I thought I'd just write this little tool for this. But that's it for today, so thank you, and bye.